before the Tera's main backplane can be populated with circuits and connectors, it goes through a rigorous X-ray inspection to identify any anomalies within the layers of the board. This happens in-house at IHSE to ensure quality. Suspect cords are discarded.
So, if any question, if there is any question, you can also go to Waldemar or so, right? Thank you.
Ja, wir machen Frühstück.
You know something about reflow soldering?
Reflow? Is that what you said?
Yeah. It's not convection. You know the normal ovens where you do soldering, these inline processes, for example, right? They're transporting the PCB over a certain reach.
Okay.
And there's temperature applied, and the temperature is up to 300 and something degrees, which is quite a stress to all the parts and so on.
Okay.
And they have to apply it in order to make sure that every single location reaches the necessary temperature of 237 degrees or something.
Okay.
Right? And here we do it differently with a reflow or vapor soldering. You have a fluid which is brought to 242 degrees and or 243 something, right? And above the liquid there is an area where you talk about 100% humidity. And people always believe that 100% humidity is equal to wet.
Right.
Right? But this is not the case. I mean, 100 or to be in the liquid. But this is not the case. It simply means that you have an area where you have a kind of a total heat transport. Okay? And so this is right on top of the liquid. It's not in the liquid, but it's on top of the liquid. But there is a guarantee that at any spot there is a good thermal transport, and there is a guarantee that it has exactly the 240 whatever degrees, right? But not more. It's not necessary.
Right.
Right? There's no spot with 250 plus degrees. Okay? It's like steam cooking rather than boiling.
And there's a flux or a paste or something on there that
There's a flux
condense where it needs to be.
Exactly. And the solder material, it's of course melting above 220, right? And this gives it now enough time. It's now gaining temperature, right? And as soon as it reaches a certain temperature, this is something you can watch here, how the temperature comes up. And all of a sudden, it's basically now that it should become liquid.
And it absorbs it to the solder joints.
Exactly. Yeah. It's now happening, and now we keep it here for a certain period of time. And due to the large board, we take 90 seconds, right? And now this 90 seconds, afterwards we're quite sure that even under the big chip, right in the middle, the temperature has been reached. And now you might understand if the bottom part of the heat comes, of course, directly through the humidity, but it also needs to be from the bottom. If you're on a cold bottom, right, on a cold floor in winter, then you won't feel comfortable even if the room is warm.
Right.
Right?
Right.
And so the floor, the bottom must also become warm. Okay? And if this temperature is not properly reached, then you can have problems with the solder quality. And this is achieved right now. So there are 30 seconds left. Macht er jetzt Vakuum oder was? Ja, ja. Hat er vorher gebacken gewesen? Ja, ich habe das angenommen von der Lichtqualität. Ich hoffe mal jetzt, dass ich auch... Okay. So now it's 10 seconds left. Now it will come out of the out of this phase. Okay. Now it's going to the vacuum process. And now you will see the light coming and flashing, right? Because now we need the heat. Now happens something. There's liquid. There's this adiabatic cooling, right? And we need the temperature there, because if the temperature drops too quickly, then we lose. That's now vacuum being applied. Now to 70%, now to 95%. Now it goes to full power. Now it's stopped. This is the period of time where we try to put the bubbles together and draw them out.
Yeah.
Right? And now it's done. Now it's already been probably cooled down to a point that nothing could happen anymore and nothing could be improved anymore.
Right.
But that's why you need these heaters there in order to apply enough heat while it's going upwards, so that it doesn't lose its. Okay, now we probably have to wait for it.
Was it cool?
That's another minute. Here we go. Beautiful.